Hello, my name is Hayden McRae. I'm currently located in Melbourne, Victoria, Australia, and I'm undertaking a Bachelor of Global Logistics and Maritime Management. The presentation today will last for about 15 minutes. If English isn't your first language or you find it hard to understand me, please feel free to enable subtitles or closed captions by clicking on the button below. In the spirit of reconciliation, we acknowledge the traditional custodians of country throughout Australia and their connections to land, sea, and community. We pay our respect to their elders, past and present, and extend that respect to all Aboriginal and Torres Strait Islander peoples today. My case study today will be from the article documented Warehouse Management with Lean and RFID Application, a case study. The authors are James C. Chen, Chen Huan Chen, So Bi Huang, Hangzhen Wang, Chen Zhong Hyung, He-Chen Ting. And apologies if I've mispronounced any of their names. This is published in the International Journal of Manufacturing Technology on the 18th of May 2013. It's accessible through Google Scholar and the UTAS library. Search keywords RFID, warehouse management, and lean management to find the article. The case study surrounds a distribution center which has an inventory of 10 million parts and 10,000 SKUs. So roughly 10,000 storage and retrieval operations take place per day across 10 warehouses, which service approximately 15 primary customers. So what is lean? Well, Richard explains that the concept of lean comes from a manufacturing sector, more specifically the automotive industry, and is very much associated with Toyota and the Toyota way. Lean is now being applied not only in manufacturing, but also within the public sector and supply chain. The idea behind lean is to remove any activity or waste that uses resources but doesn't create any additional value. Warmack and Jones simplify the lean process by identifying and eliminating waste in a product or process. 7 wastes that are investigated in this case study are overproduction, waiting, transport, inventory, overprocessing, motion, and defects. 2 major wastes were identified and needed to be reduced or eliminated in this case study were the waiting and unnecessary motion. How do we lean up a process? Singh, Garag, and Sharma state that a particular product or product family or process needs to be first identified as a target for improvement. A current state map is then drawn, and that is a snapshot capturing how things are currently being done. This is accomplished by boots on the ground, by walking along the actual process and identifying the waste and weaknesses along the routine. Wastes are then analysed and eliminated by rationalisation and or the application of technology, which is in the case of this case study. Finally, a future state map is developed as a picture or a snapshot of how the system should be done after removing the waste and inefficiencies. Future state map becomes the basis for making necessary changes to the system. So the challenges that this organisation faced were their volumes were increasing and a greater variety of products needed to be stored and retrieved. So due to that, a warehouse management system or a WMS with a better effectiveness and efficiency was needed. In the current operations, was identified as inefficiency was identified because of poor management and slow manual operations, resulting in low throughput, long lead time, and high labour costs. So we're talking about things like congestion, long waiting times, idleness throughout the process, wasted labour, turnaround times being quite long from receivable to dispatch, and quite a lot of space was needed for this process. Currently for this process. So when the leaned up operations took place, it was changing storage location from a random spot to a fixed location, creating shorter travel times for the pickers, um, adoption and implementation of new technology or technologies, improvement of data input and transfer, um, and a lowering of operation costs. So this figure point one is the current operation process in the warehouse. We can see that the material flow shows that we'll start with order flow. So the order comes in from a customer to the warehouse, and then that information is passed on to the manufacturer to produce goods and then get delivered. They're delivered to the warehouse, and as you can see under that warehouse umbrella, we've got receiving, storage, picking and sorting, packing, and then shipping and dispatch. So and that material flow means the goods will then pass on to the customer. Figure two is the current state of the map warehouse. So we can see we've got some times put in here as well. That when the goods come from the manufacturer to the warehouse on a weekly basis, um, they're received, then goes into the storage, picking, sorting, and then packing, and then shipping back to the customer. And you can see that flow chart there with the blue indicating information and being transferred. Um, Now, quickly we can just see just in the bottom left there that there is a period of 45 days um, between stages between receiving and storage. So that will be addressed later on. But as you can see right there in that figure, there's a very standout figure that quite a lot of time. Um, this whole process from receiving to shipping is 1,301.5 hours, with only 5.4 hours of value added time in that. So the current receiving and storage process is identified here in the figure three. Um, the manufacturer ship goods to the warehouse. The operators manually count and collect pallet case and product receipt information. Um, The operators check the item quantity. If it's incorrect, it will get rejected and sent back to the warehouse. The next step will be superiors will inspect the specifications of the product. If it fails there again, it will go back to the manufacturer. From there, operators manually scan and key in goods, and that information is passed on to the warehouse management system. And operators manually key in goods information to superior information system before operators finish receiving of goods and put away to storage. So as we identified in the previous slide, the goods sit and wait for approximately 45 days before inspection and clearance for storage. And this is going to be a major focus on the lean process for this case study. 45 days seems a long time, but the reason why I identified in the case study was that goods were coming in at random volumes and times, and therefore for them to be manually inspected and checked, staff had to travel to every site, and it was unknown when the goods were coming and how they were coming, and there was a lot of planning and downtime surrounding that. So, um, so moving on to the current picking, sorting, packaging, and shipping process flow chart. You can see the operators receive the order picking request. The operators generate the shipping orders, then onto the operators pick and sort. Moves on to operators manually scan, count, and capture pallet case and product shipping information, which is very labor intensive. Operators check the item and quantity, and if it's incorrect, we'll go back to they'll have to go back and pick and sort. So that's just a little bit of a loop there. Then if the operator check item and quantity is correct, operators pack and manually key in the goods again, goods information, adjust the account. Then the operators manually key in goods information and report it. And then the operators load it onto the truck and ship. So those blue stages in the flowchart there, areas that will be leaned up. They're very labor intensive, and there can be errors involved, which impact accuracy. So those processes also impact the speed in which the data is transferred to relevant stakeholders. Um, Current operations also state that receivables dock is also used for dispatch of goods, which will also add to congestion with that idle time of goods sitting on the dock before they're actually inspected and received and stored away. So we move on to technologies that can assist in the lean process. And RFID is one of those. And what is RFID? Hayes explains that radio frequency identification, known as RFID, is a technology that uses radio waves to passively identify a tagged object. It is used in several commercial and industrial applications, from tracking items along a supply chain, keeping track of items checked out of a library, for example. Radio frequency identification, or RFID, is a type of passive wireless technology that allows for tracking or matching of an item or individual. The system has two basic parts: tags and readers. The reader gives off radio waves and gets signals back from the RFID tag, while the tag uses radio waves to communicate its identity and other information. The technology has been approved since before the 1970s, but has become much more prevalent in recent years due to the usages in things like global supply chain management and pet microchipping. Cost is a major factor. Costs have also dropped in the recent years, which have made this technology more viable. Wang et al. Also illustrates that RFID-based digital warehouse management systems helping in a warehouse setting by improving operation efficiency, utilization of warehouse capacity, and inventory accuracy, as well as reducing manpower and loading time. So they're all things we identified earlier that need to be fixed. Figure 5 shows the RFID equipment used in this case study. As you can see, we have the reader. So we have the handy reader, which is used by people when picking, and the UHF passive tags, which is applied to pallets, cartons, and individual items. Typical RFID frequencies available in markets include low frequency, high frequency, and ultra high frequency. And in order to facilitate receiving and shipping processes in the distribution center, a supply chain, long range RFID for a read range of up to several meters is required. UHF RFID equipment operating between 922 and 928 megahertz ranges is adopted in this study, including the fixed reader, the handy reader, and passive tag that we've just gone over in Figure 5. Cross-docking is also identified as a solution to the inefficiencies experienced in this case study. According to Essex, cross-docking is the practice of unloading goods from inbound delivery vehicles and loading them directly onto outbound vehicles by eliminating or minimizing warehouse storage costs, space requirements, and inventory handling. Cross-docking can streamline supply chains and help them move goods to market faster and more efficiently. For one thing, setting up a cross-dock terminal requires significant planning and design, and the process must be closely monitored to ensure it's working as intended. Figure 6 there just shows briefly what cross-docking looks like. Instead of goods going into storage, they can just pass across the dock and into the outbound dispatch truck. This is an example of future operations with RFID incorporated. You can see the RFID tag is applied to the crate, will pass through the receiving door where there's RFID readers and antennas. From there, the normal process may take place. Inspection. Once inspection is complete, it can either be cross-docked and packed and then dispatched, going through the readers. Those stock counts can remain be in real time. Otherwise, they will go into storage, and the process, as soon as they're picked and packed again out the dispatch door, that data will also be recorded in real time. So this is the future operation process, lean and RFID flowchart. We still have all the main components listed in current operations. However, real-time identification and checking of parts received is done in receiving RFID tags to be attached to the pallet cases and items, as explained earlier, using an Ethernet connection with the warehouse management system. All that data is transferred um, from the RFID receiver at the receiving dock. With the picking and sorting stage, real-time identification and checking of parts picking and sorting is completed. And then when the item is shipped, real-time identification and checking of parts shipped can be completed from the RFID reader at the gate. And that uses that Ethernet connection as well to transfer that data. So the future operations we can see in the future value stream map with lean and RFID incorporated in figure 9 here. We can see that times have been sped up, a reduction of idleness. It's very important to see that the time between receiving and storage has dropped dramatically. If you're a bit confused, the bottom rung of that flow chart incorporates cross-docking. So we can see that speeding the process up dramatically. So with this technology introduced, the RFID technology will reduce the time of checking, reduce the time of reporting, but also reduce picking and sorting time, and reduce the time of reporting when the item is shipped out. So future receiving and storage process. The blue boxes here will show the differences from the original process. So the system automatically counts and captures pallet, case, and product receipt information as soon as it goes through the receivable dock. The operators check the item quantity. If that comes up on the system as correct, we'll move on to the inspection phase. If not, it'll be rejected and returned to the manufacturer. Same as the inspection phase, once again, that needs to be done. If it's not identified the goods are up to spec, it will be rejected as well. But from there, the system automatically scans and records the goods information and adjusts the account, so which reduces that time that the data is sent. The system automatically generates a report to superior as well. But the operators can finish receiving the goods and put away in storage if needed. So those blue boxes there really highlight the efficiencies created. The future picking, sorting, packaging, and shipping process. Once again, the blue boxes highlight the areas of efficiency gained. Once again, the operators receive the picking request. Operators generate the picking orders. Moving on to picking and sorting. From there, the system automatically counts and captures the pallet case and product shipping information. And then it goes on to the operators will check the item quantity on the system, on their reader. If that is incorrect, we'll go back and redo a repick. Operators pack and the system will automatically adjust the account. System automatically generates the report then as it's loaded onto the trucks and shipped out, all through the help of the RFID technology. So these outcomes and measured outcomes from the implementation of RFID and also cross-docking. This is a table identifying at every single point the efficiencies gained, which marry up to the blue boxes we've already discussed in the flowchart. But basically, the RFID process automatically captures and uses the information, which is shorter process time and less labour are required. So the total time saved by using that RFID in these processes from receiving to shipping is 190 minutes, which is quite large. And the total time comparison for the 4 scenarios, this graph here at the top will show the 4 scenarios without the lean process, with a lean process, lean with RFID, and also with cross-docking that incorporates the lean process and RFID. I won't go through those numbers. Those numbers are there, but the graph below in Figure 14 really paints a picture that before we're talking about the total time before lean or RFID was 1,301.4 hours spent per product, or with the lean, that time has been dropped to 269.1 hours, a reduction of 79% in time. But when you incorporate RFID in with that lean process, that figure drops further down to 171.9 hours used. And then once again, once cross-docking is implemented with the RFID and lean, we can drop that process to 121.9, which is a 91% saving of time. Figure 15, performance improvement in value added time over 4 scenarios. There's a lot of data there, but the red numbers instantly show you the savings made in minutes, but the table below in Figure 16, the improvement levels are shown in minutes, really paint a picture of the savings made that during the receivable time process without lean and RFID, 91 minutes compared to 17 minutes with lean and RFID and cross-docking. So a rate of improvement of 81.3. It goes through and shows that storage time was also dramatically reduced by 95.6%, packing time 60%, and shipping time 99.8%, which is just phenomenal. So once those goods go out the door, the RFID technology and cross-docking allow for a huge saving there. So in conclusion, we can see that the implementation of lean process and RFID, and also combining that with cross-docking, has had significant savings for the business. So data processing times during receiving has been a 99% saving, and when shipping, it's an 89% saving. Total operation times using lean only is reduced by 79%. When you incorporate RFID into that lean process, it's reduced it by 87%. But when all three, lean, RFID, and cross-docking, are incorporated in this case study, there's a reduction of 91% in time. Thank you for your time. Sorry I ran over. There's a lot to cover, but I hope you took something from it. I certainly did. Thank you very much.